Ego Power Station. I'm going to do a little efficiency analysis because my impression is that there's a lot of efficiency losses through the inverter. So, one of these batteries might have 340 watt hours of power in it, but I suspect you're probably only going to get 250 watt hours out of the AC side of things. So let's go do a little test on that. Okay, I've got this guy set up with 4 of my 7.5 amp hour batteries that are essentially completely charged. I've just used them to show off the cell phone charging and so forth. Just sitting here, it's doing 107, 108 volts, and the frequency is 60.6 hertz. So, this is within the range of acceptable for AC power. Now, when I turn on the heater here, we're going to start drawing power, and the fan will probably turn on here, so you'll be able to hear what that fan sounds like. Of course, there will also be a heater fan. So I turned on the heater. I'm running the heater at its lower setting. So what that means is I am drawing about 800 volt amps or 845, 860 watts. So I'm not drawing the full amount this heater could do. If I flip it to the full setting here, you'll see that this heater will draw more. So we're, up to 1400 watts. So I'm doing like 1400 watts into that heater at its upper setting. I'm not going to run it at that way continuously because I have this power meter in here and I don't want to run that many watts through the power meter continuously. So right now that fan you're hearing is primarily from the inverter here, the Ego Power Station. There is a fan in the heater, but this fan is louder. So the loudness you're hearing is from this guy. When I turn this down, the fan here is even a little bit slower. This guy, the fan, that's kind of as loud as it's going to get. You can hear it, it's pretty loud, but you can hear me talking over it. It's not horrible. I put this thing outside of the tent instead of in the tent type of thing. And so now we're doing 800 watts, and the fan might slow down a little bit here. So I'm going to let this guy run. You can see the prediction here is it'll run for an hour and 20 minutes. We'll see how long it runs. This guy keeps a running count of how much power we've used. So we've used 0.02 kilowatt hours. So we've used 20 watt hours so far. And this will count up as we go. So what I'm going to do, and also has an elapsed time counter on it as well. So what I'm going to do is basically see how long it goes until it shuts down. And then I'll charge these 4 batteries and tell you how much power it took to charge them back up. So we'll get a total efficiency system measurement. So we'll say, how much power did I deliver to the load versus how much power did it take to charge these 4 batteries back up. And that'll include the losses of the chargers as well as the losses of the inverter. Now you can hear the fan just crept down to kind of a mid-level. So now the heater fan you can hear. I think this fan is louder. But you can hear the heater fan in addition to the fan on the inverter. And so right now, it's drawing 800 watts. So this guy is running at a kind of a mid-level on its fan speed setting. So I'm going to let that run. We'll come back when it turns off and see what the total power usage was. So if you want to see on the Bluetooth app here, every so often it doesn't find the app. You have to cancel out. And then go back in and hit the thing and say try to find it where the Bluetooth icon lights up and it shows up here. So the battery level now it says is 83%. It started out near 100%. The usage it says is 920 watts. This little power meter here says the usage is 811, 815 watts. So, it depends. Do you trust the Kilowatt EZ or do you trust Ego? But it's, in the 800 to 900 range. And its estimate is about an hour remaining here. And you can see that, each of these batteries here, it's trying to draw them down at about the same rate. So they're all about 80%. And I can demonstrate turning off one outlet. So there I turned off the outlet that the heater was attached to. And so the power draw is down to 0 watts now. When I turn that outlet back on, I will have to turn the heater on manually because it's a digital control. So now I turn that heater back on. You can see the fan turn back on. And now we're back up to 900 watts of usage. I started this thing up about 40 minutes ago, and it said it had an hour and 20 minutes of runtime, but the estimate has gone down. It was down about 15 minutes when I first came out here. When I started recording, it's dropped down to 9 minutes. So it doesn't look like it's going to be running this thing for the full hour and 20 minutes it predicted. We'll see if it hits an hour, and we'll be able to see the total power usage when we're done anyways. This guy, the power meter, remembers how much power things have used. So it's 44 minutes it's been running, and the total usage here, that's cost. There we go. So far we have 0.56 kilowatts, so half a kilowatt delivered. So if you look at my app here, you can see that some of my batteries are lower than others. These batteries are not all the same age and capacity. It's supposed to try to run them down kind of on its own, kind of evenly. 2 of them are marked as low power and 2 of them are marked as green but smaller down. If you look at the display here, it has kind of a 5-dash battery bar system, and so this guy has 1 dash, that guy has 2 dashes, and these 2 have 0 dashes. So I suspect what's going on here is when individual batteries hit their low voltage cutout, it basically cuts them off of the system. So probably it's running it off of only 2 batteries now, and 2 of the batteries are not being used. So this guy shut down. I'm going to try turning it back on. The load is off, so hopefully it'll turn on and run for a little bit here. Alright, it's up and running. I'm going to connect to it and see if I can get a read on those batteries through the app. Alright, there's the app, and you can see battery 1 is low power at 4%, battery 2 it claims has 42% left, battery 3 is at 15%, and battery 4 is at 43%. Now it did shut down, and I suspect it shut down because all of the batteries had gotten pretty low, because when you draw 1,000 watts or 800 watts out of this thing, the battery voltage are going to drop down. I'm going to take out battery number 1, and we're going to try to run this heater for a little bit longer. So I'll turn on the outlets, turn on the heater at the low range, and let's see what it says. So we're down a battery. It says the time remaining is, well, 28 minutes now. So the usage is about 970 watts. That'll go down to probably 800 watts as the heater heats up. So you can see here, 1 battery hit low power, it shut the whole thing down. This battery number 3 is at 14%, so it's pretty low too. I'm going to let it run a little bit longer, and we'll see if it's able to run for much longer with that other battery taken out. Alright, just a minute later it went into low power. It's no longer giving an estimate of how long it's going to last. So I suspect one of the other batteries, so battery number 2 here has gone into low power mode. Now it's still drawing from battery 3 and battery 4, but we'll see how long this lasts. I don't think it was the 20 minutes it was kind of estimating just a little while ago. Alright, now we have all 3 of the remaining batteries at low power, and it shut this thing down. So I'm going to say that, we're going to take out battery number 3, see if we get any extra runtime, but I think it's mostly the batteries are pretty much done. And the batteries are numbered, so there's 2, 4, and then 1 and 3 here, so if you try to figure out which battery is which, it's pretty easy to get the numbers there. So let's turn this back on with just the 2 batteries. Alright, so I have my 2 batteries at 34 and 28%. I'm going to turn on the outlet, turn on the load. Alright, it says the load's just a little under 1,000 watts. Predicting down to 13 minutes now. We'll see if that lasts anywhere near the 12 minutes it predicts. My prediction is it's going to go down a lot faster than that. Yeah, we've already hit the bars there. You can see it's low power. Let's see. So 26 and 33, that battery 2 is low power, battery 4 is low power, and it shut off. So I'm going to say that we've used all of the usable capacity out of these batteries. Okay, so let's recap what we've done here. Our total runtime was 53 minutes on the heater drawing about 850 watts. We have, let's see, 0.66 kilowatt hours. So we used 0.66 kilowatt hours. So 660 watt hours is what we got out of the inverter. Now I'm going to take these 4 batteries over to my charger. I'm going to use this same meter to charge them back up, so I'm going to charge them one at a time, and we'll see how much total power we put into those 4 batteries to charge them back up. Okay, I am resetting this power meter. So we have to remember the 0.66 kilowatts is what we used. And that power meter powers one of these Ego fast chargers. I'm going to charge these in the order that they were listed on the power station. So this is battery number 1 in the power station. This guy is the 3rd generation Ego battery with the 5 display battery gauge. And you can see here it's 80% charged and it's working on that last 20%. It's been charging for about 50 minutes. So it gets up to about 80% in about 50 minutes, and then it slows down a bit to get that last 80%. So this 7.5 amp hour battery has been charging for exactly 1 hour, and you can see that the 5 little display is turned off. This guy's solid, but the charger is still pulling power. So it was 60 watts just a little while ago, now it's down to 46. I think what's going on here is it's blowing the fan to keep the cells cool. It might be topping up just a little bit of extra charge into the battery. So what I do when I measure these batteries is I let it run until the fan turns off and this goes down to 0 watt draw. And so I don't really claim it as being fully charged until that happens, although right now it probably has 95–98% of the total capacity into it. So if we look at the total usage here, it has 380 watt hours that was put into this one battery alone. That includes the capacity, the loss due to charging inefficiencies and running the fan and that type of thing. So it's at 0.38 now. We'll come back and look at what it's at when it gets done with the fan. Okay, I came back out. It's been an hour and 18 minutes since I plugged this guy in, and it has stopped charging, and the total amount of power used was 390 watt hours to charge this one battery. I am starting battery number 2 on the charger. I'm leaving the watt hour counter alone, so we're just going to add watt hours to the total from battery 1. The total charging time has been 2 hours and 30 minutes, and our total power going in is 580 watt hours. So that means, compared to the 390, that's only about 190 watt hours into this battery. This is my battery from 2017 that I have marked as kind of low capacity and that it won't run the lawnmower. It'll just shut off if it runs the lawnmower. So it's 340 watt hours if drawn at 60–80 watts. So we were drawn out of it a lot faster than that. So that makes sense that this battery has less capacity than the others. Here is battery number 3 starting its charge. Battery number 3 is finished charging. So far we've spent 3 hours and 52 minutes charging, and the total amount of power we've put into the 3 batteries is 920 watt hours. So that means this battery got 340 watt hours more than where we left it with battery number 2. This is a 2019 battery, and about 340 watt hours is kind of what I would expect to have to put back into this battery after using it to mow the lawn and running it down mowing the lawn. Alright, I'm putting battery number 4 on. This is another one of my batteries. This is the 2018 battery that does not run my lawnmower, but I can get 340 watt hours if I use the smaller inverter to get about 60 watts out of it. So we're going to run this guy up and see how many watt hours it takes to fully charge all 4 of them. Battery number 4 is done charging. We are up to 1.05 kilowatts or 1050 watt hours, and it took us about 5 hours to charge all of these batteries. There was a couple of minutes here and there at the end of each battery when it got done charging before I came to check on it. But essentially, we can charge 4 of these batteries in 5 hours using one of these quick chargers. And the Ego Power Station plugged in takes about 14 hours to do the same thing. So this battery here only had 130 watt hours added back to it. So I have my 2 weaker batteries that had 130 watt hours and 190 watt hours added to them. And my 2 stronger batteries had 340 and 390 watt hours added. So it looks like the power station is drawing down the batteries but taking less capacity out of the weaker batteries, which kind of makes sense. Took 1.05 kilowatts or 1,050 watt hours to charge my 4 batteries. We drew out 660 watt hours. That means there's 390 watt hours missing due to loss. Now that's due to inefficiencies, converting AC to DC when charging the batteries, and then converting that electricity to chemistry in the batteries, and then doing the chemical to electrical transition back out to DC, and then the DC to AC inverting coming out of this guy. So total system losses is about 37%. A little higher than I'd like to see, but not unreasonable. If we're generous and we say half of that is charging and half of that is on the inverter side of things, that's about 18% on each of those. So that would make this inverter something around the range of 82% efficient, which is not unreasonable for an inverter to do. I'd like to see 90% on both the inverters and the chargers, but it's in the range of reasonableness. But you're not going to be winning any awards for efficiency with this system. Alright, I calculated 37% total losses from charging through the batteries, into the inverter, and back out to the load. I'm going to run this test one more time. I've charged these 4 batteries, so I know I put 1.05 kilowatt hours into the batteries. I'm going to run those batteries on this load and see exactly how much I get out. Alright, it's been about 40 minutes, and just a little while ago this thing said I had 40 minutes left. But then suddenly it dropped down to like 12 minutes, and I pulled up the app, and I see what happens here is 2 of my batteries hit their low power cutoff, and so those 2 batteries have been cut off, and now it's pulling from these other 2 batteries, and when those batteries are out, it's out. And battery 1 and 3 happens to be, let's see, my good batteries. So these are the batteries that are doing 340, 390 watt hours. Batteries 2 and 4 are my weaker batteries. They're 190 some watt hours, 130 watt hours of capacity. So as soon as those batteries go out, everything's onto these batteries, and then the rate drops down quite a bit. So the estimate there will work well if all your batteries are evenly matched. But if the batteries have some weak ones and some strong ones, it'll be an overestimate until the weak ones drop out, and then it'll go down. Okay, in my second test I had 680 watt hours delivered, which is very similar to the 660 watt hours delivered. And it ran this guy over here for about 50 minutes. About a minute of that was just me turning things on and getting things set up. Okay, it took a kilowatt to charge it. We got 680 watt hours out, so we've lost 370 watt hours to heat and energy conversion losses and so forth. So our total loss here is about 35%, which means the total system efficiency is about 65%. That's lower than I would like, but it's not outrageously low, given that we have losses when we charge it and then again losses when we convert back to AC and power this guy. I'd be very interested in seeing what other portable power banks do. So if you fully charge it and then get a meter and see how many watt hours it puts out, and then use the same meter to charge it back up again, how many watt hours does it put out versus how many watt hours does it take to charge. I'd really like to see what the total system efficiency is on some other brands of portable power banks, they call them solar generators, that type of thing. Now I know when I have access to the fast chargers over there, it's a little silly to charge this thing with the small power brick. But we're going to plug this in, we're going to reset this guy and plug it in, and we are going to use the provided charger, the slow charger, just to get some readings on it. I'll do this overnight and come back and see what happens. So I've plugged it in, and as soon as you plug it in, if you look at the front here, it says charging, and none of this stuff's going to work. So you can't turn on any of these guys. It's just going to charge. And what it does is it charges one battery at a time and kind of goes around. And it does give you an estimated time for how long it's going to take to charge these things. It is still working on this estimate. So, it's down to about 12 hours here. But, I think 12 to 14 hours is a reasonable estimate. That's what it's taken to charge these guys in the past. Let's look at the power draw here. So you can see my house is doing 112 volts, at end of an extension cord out in the garage. The power factor of this little brick is 0.66, which is fine, it doesn't matter. Frequency of my home AC is 60.0, and we're drawing 104 watts. So these batteries are fully depleted, so they should be drawing, you know, the maximum this charger can provide, and it's charging at basically 100 watts. So you can see how this charger, you know, it's going to take, you know, 11-12 hours, whereas those chargers over there, you know, you could do all 4 batteries in about 5 hours. And just in case you want to see what it looks like when it's charging, the app does report on that. You know, it says, hey, your batteries are at 26%, 11 hours and 41 minutes to finish charging. And it tells you, you know, here's, you know, these batteries are at low power, and it says those batteries are at 45%, but I don't think they are. I think they just kind of bounced up to that percentage. The controls area is completely gone because none of these outlets work while it's charging the battery. You can tell which battery it's charging because that's the battery that's flashing. Up here, the light on that battery is flashing. All the other batteries are dark. It periodically just changes. It just kind of goes around, and it'll do one battery for a couple minutes and move on to the next one. It's attempting to kind of keep them all at about the same charge level so that if you take it off to charge, they'll all be charged about equally. So this guy is charging batteries, drawing about 108 watts. And I can physically feel heat emanating off of this thing. You know, my estimate is it's losing 10 watts of heat, just kind of being warm, sitting there. So my best guess as to why this portable power station is only charging the batteries at about 100 watts is that it does not have fans which blow through the batteries. All of Ego's other chargers have fans to force air through the batteries while they're charging them. So I suspect they're limiting this to 100 watt so that these batteries can dissipate any excess heat just passively. Alright, that brick has gotten so warm after 6 hours of charging at, you know, drawing 110 watts. I had to get out the thermal camera. You know, ambient here is 24 centigrade. This brick is up at 46 centigrade. I mean, you know, it's warmer than my hand, which is obvious because I can feel it being warm. So that guy is just wasting power as heat. I mean, the batteries are, when they're charging, have some heat coming off of them, but those are, you know, hot spots of 29 or so, whereas this guy is, you know, 45, 47 centigrade. Alright, at 6 a.m. it's done charging the batteries, so it took a little less than 12 hours. Idle draw on this guy is 7 watts. This guy does not feel very warm at all. Let's see what the total power draw was here. Alright, so 1.06 kilowatts, so that's very close to the 1.05 that we charged him up with the other charger. So apparently this guy here is just as efficient or just as inefficient as the Ego fast chargers. This is an Ego rapid charger. And when you plug a battery into this guy, you can see it ramps up the watts. And so this rapid charger's drawing almost 300 watts into a 2.5 amp hour battery. Alright, this is a Ego standard or slow charger. And I have it plugged into my easy watt meter here. And you can see it ramps up the watts as it starts charging that 2.5 amp hour battery. So you can see here, even the standard Ego charger is doing 170 some watts into this 2.5 amp hour battery. So it's, you know, 75% more, or 175% of the speed of the Nexus Power Station charger. Now, if you charge a 7.5 amp hour battery on one of the Ego fast chargers, this guy's putting in 440 watts here.